Hello and welcome to our series of introductory Java tutorials. In these podcasts, I'll demonstrate the process of creating a complete Java program from start to finish. In this video, I'm going to do an example that includes the use of data types, casting, and basic arithmetic. In this example, we'll write a program to calculate the light distance. That is the distance, or the time, that it takes for light to travel a given distance. So if we use the speed equation, the speed of a particle or a wave of light is the distance that it travels divided by the amount of time that it takes. If we rearrange that equation, we can solve for the time. So if we take the distance and divide that by the speed that light travels, we will get the amount of time it takes for that light to travel that distance. If we use the speed of light in kilometers per second and we use the distance in kilometers, then the units will work out to seconds. The time units will work out to seconds. And I've written down at the bottom of this screen the speed of light in kilometers per second. So one of the things to do when you get started writing a program is to sit down and think through the entire process of the program. Write down the purpose, the input, the process, and the output for your program. So that's what I've done here. For this program, I want to calculate, the purpose is I want to calculate the amount, the time that it takes light to travel a given distance, where the input is a distance in kilometers. And the process is I want to use the speed equation that we just looked at to compute the time it takes the light to travel that given distance that we took as input. And finally, the output is the light distance in hours, minutes, and seconds. And before we get started, it's always a good idea to write down test data for our program. So in this case, I've written down some example inputs and the expected output. One of the things you want to do when thinking about test data is to test not only valid inputs, but test the boundaries of those valid inputs. So for example, I've tested a typical normal input, which would be something like 149,600,000 kilometers, which is the distance from the sun to the earth. But I've also included things like 0 and 1, and I've also included larger values, say on the other end of the range, like 3.9 times 10 to the 13th kilometers. You could go even farther and put down test data for incorrect input, but I haven't done that in this case. Okay, I'll get started by typing in the basic template for a Java program. That includes a class definition plus a definition for the main method. So I'll start with the class definition, public class, and I think I'll call this class light distance. So the general style is to, if you have multiple words in an identifier, is to capitalize all of the following words in the identifier itself. In the case of a class name, it's also common practice to capitalize the first letter as well. So light distance with a capital L and a capital D. And then I'll put the two brackets to define the body of the class. And inside the body of the class, I'll put the main method definition. And the two brackets for the body of the main method. So that's a good template to start with. This is something, again, that for now you can just write down and remember. Later on in the class we'll be able to understand all of the details of this code here. Okay, before I go too far, I'm going to go ahead and save this file. And I'm going to remember to save the file with exactly the same name as the class name, with the .java at the end. Okay, so now that I've saved it, I'm ready to get going. And in fact, this program right now is at a point where I could compile and run it, even though it wouldn't do anything. And it might be a good idea to compile and run this if you're typing along, just to make sure that all of the code that you've written in so far is syntactically correct. Alright, I'm going to go back up to the top and add an import statement. Because I know that I'm going to need the scanner class for user input later on. So I make sure that I import that ahead of time so I don't forget to do it later on. Okay, so to get started with the main program, I'm going to begin by thinking about the variables that I'm going to need and what their data types need to be. So the first thing I know I'm going to need is the speed of light. And that is a double precision number. It has a fractional part. And it's something that's not going to change in my program. So I'm going to go ahead and make that a final variable, a final double variable. And I'll call it light speed. It's again common practice with final variables to capitalize all of the letters of the identifier and to use a underscore to indicate breaks between words. Okay, so I have that. I'm also going to need a few variables to hold the intermediate data that I read in and calculate with. I'm going to read in the distance in kilometers. That could be a fractional number, so I'm going to use a double for that. And I'll add a comment to indicate what the variable is for. I also need some variables to hold the time. The time is going to be expressed in terms of hours, minutes, and seconds. So I'm going to use integers for that because it doesn't make sense for me to have a fractional value for the hours, minutes, or seconds. I'll declare all three of those on a single line and just add an extra comment at the end to indicate what they're for. I'm going to have one more variable to hold the total time in seconds, because when I plug it into the equation and actually calculate it out, it's going to give me the total seconds, which I'm then going to convert into hours, minutes, and seconds. So I'll use an integer for that as well. Now you could use a double there, although basically for this program I'm not going to worry about fractional seconds. I'm essentially going to throw them away. So I don't really care about, for this program I don't really care about fractional seconds, so it makes sense to use an integer here. There are other reasons you might want to use a double for the total time in seconds, and that has to do with the precision of an integer. Basically how much data I can fit into an integer. Now I'll come back to that a little bit toward the end, but for now I'm just going to use an integer for this. Okay, one more thing I need is a scanner object that I can use to read input from the user. I'll call it scan. I'll declare the variable for the scanner object on this line, and on the next line I'll create the object using the new command. Okay, now I think I have everything that I need. I'm going to actually write the code to read in the input from the user. I'll add a comment here. And then I'll add a print statement. I like to use print instead of println or print line, because if I use a print statement, the input will be typed on the same line as the prompt, If I used a print ln statement or print line statement, then the input would be typed on the line following the prompt. And again, it's just a matter of style as to which one you prefer. Okay, so I've got my prompt printed. Now I'm just going to read in using the next double method from the scanner class. So I'll call the method next double using the scanner object, scan.nextDouble. Now that returns a double precision number, basically the value that was read in from the user. So I've got to store that in a variable. So I'll go back to the beginning of this line and assign the result of the next double call to our variable distance in kilometers. So after that, I should have the value of the user's input in my variable distance in kilometers. Now I can calculate the total time in seconds. And that, if you recall the equation, that's just the distance in kilometers divided by light speed Now, distance in kilometers is a double. Light speed is also a double. So the result of that equation is going to be a double precision floating point number. But I'm trying to assign it, trying to store it in an integer variable. I can't do that. That's not allowed by just as it is. Instead, I need to apply a casting operation to make that assignment work. So I'm going to cast using the int cast operation. So I'll add int in parentheses just before the division. Okay, what that does is it essentially just drops all of the fractional part of the result. So it rounds it. Sorry, it doesn't even round it. It just truncates the fractional part of the result, and stores that, and stores the nearest, or stores the whole number into total times in seconds. All right, so now that I have that number, I need to convert it into a representation in terms of hours, minutes, and seconds. So for example, if the total time in seconds was 60, then it would convert to 0 hours, 1 minute, and 0 seconds. If it was 3600, for example, it would convert it into 1 hour, 0 minutes, and 0 seconds. So I'm going to do that using a couple different operations. The most important operation and the most useful operation for doing this is the mod operation. So to calculate the total number of hours that this corresponds to, I'm going to take the total time in seconds and mod it, divide by 3600. If I divide and both of the operands of the division operation are integers, then the result will also be an integer, and it will essentially, again, just like the int cast did up above, it will essentially throw away the fractional part. It will throw away all numbers to the right of the decimal point. So if I do this division, total time in seconds is an int, and the literal 3600 here is also an int because I've expressed it without a decimal point. So that should give me the result that I expect. That will give me the total number of hours that it corresponds to. Whatever's left over, I want to use to calculate the number of minutes and the number of seconds. So how do I calculate the minutes? Well, I need what's left over. So one of the ways to get what's left over is to take the total time and mod it by 3600. That'll essentially give me the remainder of the above division operation. Okay, so if I take that, that's how many seconds I have left over after I've sort of extracted the hours. And then I can divide that by 60 to get the number of minutes. And again, I'm using all integers in these operations, so it will truncate or throw away the fractional part. Finally, to get the number of seconds, I need basically just the number of seconds that are left over after I've extracted the hours and the minutes. And one of the ways to do this is to just take the total time in seconds and mod it by 60. That'll give me the remainder if I had divided it by 60. Now, it may take a few minutes to sit down and think about that to see that that actually works correctly. You might want to think about some example data for total time in seconds and see if that works. Alright, so finally I've done that calculation. Now I can just print out the results. So I'm running out of room on this line, so I can go ahead and break the line. There's no problem with ending a line in Java, even in the middle of a statement, as long as I don't do it inside of double quotes or inside of a string literal. So I'll just add a plus here and just go down to the next line. And there I'll end my print statement. Okay, I'll go ahead and save. And then I'll compile and run and see if it works correctly. So to do that, I'll go down to my console down at the bottom, and I'll navigate using the cd command to get to the directory that has my Java file in it, which I call demo. I can type a dir just to make sure that the file is actually there, and there it is. So I'll compile using the javac command. And if that works, which it did for me, I'll just go ahead and run it using the Java command. Okay, so to test it, I'll use the test data that I wrote down earlier on. For the distance from the sun to the earth, we had 149,000,600,000 kilometers. Now I know that it takes about 8 minutes for light to travel from the sun to the earth, so I should get about 0 hours, 8 minutes, and 19 seconds. Yep, and that's what I got. Note that the output shows the distance in sort of a funny notation, 1.496 E8. And that's the scientific notation that's used by the Java language. And it essentially what it means, 1.496 E8 means 1.496 times 10 to the 8th. And you can actually express numbers like that within Java programs as numeric literals, which I didn't do in this example. But in fact, I could actually run this program again, and instead of typing in 149,600,000, I could just type in 1.496 E8. I can even use a lowercase e, and Java will still understand that as a valid floating point number. All right, so that one gives me the correct output. So I'll run it again and try it with the other test data that I had. So 3.99 times 10 to the 13th is the distance from basically our solar system to the nearest star called Proxima Centauri. I'll enter that one, and I get the expected output, 36,970 hours, 1 minute and 13 seconds. Now that actually corresponds to about 4 light years or so. So I'll run it with the other input. I wanted to test 0. 0 works correctly. I want to test 1. That also works correctly. And we're getting 0 seconds because basically we threw away any fractional seconds. It takes light less than a second to travel, obviously, to travel 1 kilometer. Okay, and finally, the last one I want to try is 299,792.459, which is the speed of light, basically. So I know that light should take basically 1 second to travel that distance. And that's what we get. Okay. So this program is working on our test data. There's a couple things we could do to improve the program. One of the things you might want to think about is, what if the user puts in, say, the distance between Earth or the solar system and a farther away star, say one that takes that's a million light years away. If they enter a number that large, then our program may not work correctly. And the reason is because we're using integers in certain locations in our program, and those integers are finite. There's only a certain scale of number that we can store in an integer. The integer tops out only at around 4 billion or so, or 2 billion or so. So you have to be a little bit careful when you're doing calculations with large numbers like this. Okay, so that's it. Thanks for watching, and we'll see you next time.